Alright, Algebra 2, here we are with section 2.1, Relations and Functions. Emphasis on the fun. Discrete relation is a relation where the domain is a set of individual points. Alright, the points are just scattered, they're individual, and you're able to count them. Okay? As opposed to a continuous relation, where our domain is going to be made up of infinite points that can be graphed with a line or a smooth curve. Okay, there's no way I could go through and count all these points. Alright, so that's going to be a continuous one. It's a smooth curve. Alright, where you don't have to pick your pencil up, and it goes on forever in both directions here. Same thing with a line would be continuous. Your normal y equals 2x plus 3, something like that, would be continuous as well. Okay, remember from Algebra 1, a function is a relation in which each element of the domain, your x's, is paired with only one element from the range, the y's. Okay, so if we were looking at like a list of points, we had 1, 2, 4, 5, 6, 8. Alright, 1 only goes with 2. I don't have 1 going with something else later on. 4 only goes with 5, 6 only goes with 8. So that would be an example of one that isn't. If I have 1, 2, 4, 5, and then later on I have 1, 8. Alright, I can't have 1 with 2 and 1 with 8. Okay, then that would not be a function. That's still a relation. It's still a relation like up here that we talked about, but it's not going to be a function. Okay? Notice what would happen if we had 1, 2 and 1, 8. 1, 2, 1, 8. See how the points would be stacked on top of each other? So if you're given a graph, a quick and easy way to test to see if that graph is a function is to do the vertical line test, or sometimes it's called the pencil test. Okay? Can I place my pencil down along the graph and not have it hit 2 points? Okay? It's only going to hit 1 point, 1 point, 1 point. It's only going to go through the graph once. Okay, so that one's going to be a function. We slide over here to this one. 1 time, 3, 3, 3. Okay, so it's going to be going through multiple points here on each vertical line. This one's not going to be a function. That means that we're going to have like 1, -2, 1, 1, and 1, 5. We're going to have the same x value going with multiple y values. Okay? Another thing with functions is we have what's called function notation. It's like for equations, it helps with naming them when you have multiple equations going on. Alright, so instead of y equals, we'll have f of x equals, or g of x equals h of x. Okay? So the letter in the front is kind of like the name of the equation. And then in parentheses it'll have x. That just means that's the independent variable that you're putting in. Sometimes it'll be t if it's like a function based on time. Then it'll be f of t. Okay? So, this is what you would have. Like a bunch of equations, functions here. Okay, f of x equals 2x plus 1. G of x equals x squared minus 2. And h of x equals 5. No matter what, h of x is 5. What would that look like? That's just going to be a flat line, horizontal line at 5. Okay, so f of 2. To find f of 2, I'm going to put 2 in to the f equation. So I'm going to put 2 in over here. So f of 2 is going to be 2 times 2 plus 1. 4 plus 1, we should be getting 5. Okay? A lot of the times, common mistake is that kids will try to do something with this. They'll leave 2 equals. Okay? You don't need to be using that over here. This is just telling you what equation to use and what number to put in for x over there. Okay? H of 3. Be careful, because F was underneath this one. H of 3. Don't put it in here. This is G. H of 3. So if I put 3 into this equation, well, there's no room for X. Remember, for this one, it's always 5. The answer is always 5. Negative 5, comma 5, 0, comma 5, 1, comma 5, 2, comma 5, 3, comma 5. So my answer for this one is 5. And then G of 7. So you go over here to the G equation. I'm going to put 7 in for X. So we'll have 7 squared minus 2. 49 minus 2 is going to be 47. Okay, we got an idea of how those are going to work? Good. Onward. Okay, also with functions is we have graphing. We're going to review graphing a little bit, which this should be pretty good for you because you've done this in pre-algebra, algebra 1, and some in geometry too. We should be pretty good at this. Okay, linear equations should come in the form of y equals mx plus b, where m is your slope, b is your y-intercept, which we usually use to start from. Okay? So here's a little grid. Sketch that out over here on your graph paper. Do your best to make sure those are even. Okay, if I gave you a y equals 2x plus 1. 2x plus 1. Okay, that plus 1 is our y-intercept, where we're going to be starting at. So that means we're starting at 0, comma 1. And then our slope is 2, or 2 over 1. All right, we're going to go up 2, out 1. Okay, so we start at 0, comma 1, our y-intercept, and our slope was 2, or 2 over 1. It helps to write it as a fraction. So I'm going to go up 2 over 1, up 2 over 1. Okay, and you would use a straight edge, and we would draw our line. Okay? Those are for linear equations. For nonlinear, those can be a little more difficult. You might need to make a table of values. Okay, you might need to make a table of values. If you have a graphing calculator, your calculator can do that for you. Okay? Y equals 2x squared minus 1. So I can type that into my y equals 2. We get our x from right here. It's next to alpha. It's xton. X squared is right here, kind of diagonal by the 7. Squared minus 1. Okay, you can hit graph and you'll see, get a little picture of what you should be getting, something like this. And if you see over here above graph, second graph gets us to our table. And there, it's already done for you. So if I want to make my table of points, negative 2 I can see is going to be 7. Negative 1 is 1. 0 is negative 1. 1, 7. Okay, so I can easily get that table of values. If you don't have a graphing calculator, it might take you a little bit longer to put those points in to your normal calculator and get each one of those just by typing them in individually. Negative 2, comma 7. Negative 1, 1. We're going by 2's here, notice. 0, negative 1, 1, 1, 2, 7. Alright, do your best to smooth that out. And we get something that looks pretty close to what we had before. Okay? So for nonlinear, make a table. Nonlinear meaning your x is going to have an exponent on it. Okay? It's going to be x squared. You might get an x to the third. It's going to be a curved graph. You need to make a table. Linear, you should be pretty good at those. Okay, get it into this form. Y equals mx plus b, Start on your y-intercept and follow your slope and draw your line. Alright, we got a few more function notation problems for you here. Alright. Why don't you go ahead and hit pause on the video and try some of those out. Alright, welcome back. Let's see how you did. Okay, f of -5. I'm going to be using the f equation. -5 going in there. 3 times -5 plus 2. So we should have -15 plus 2, -13. G of 4. G equation, -2 times x squared. So I should have -2 times 4 squared, and we should be getting -32. H of 1, -4 times 1 squared, minus 2 times 1 plus 5. So 1 squared is 1, -4 times 1 is -4, minus 2 plus 5. -4, -2 is -6, plus 5 should be giving -1. G of -3, -2 times -3 squared. -3 squared, be smarter than your calculator. -3 squared is going to give you a positive 9. Times -2 is going to be -18. H of -2, we got -4 times -2 squared minus 2 times -2 plus 5. Tricky one here. -2 squared, positive 4. Times -4 makes it a -16. -2 times -2 is a plus 4 plus 5. So we got -16 plus 9, -7. And our last one, f of 9, 3 times 9 plus 2, 27 plus 2, we should be getting 29. Okay? I just did those pretty fast, so there's a possibility I might have made a quick mistake there for you guys. Apologies if that happened. But you got a little extra practice there. Okay? Your homework. Alright, page 64. 11 to 35 odds, skipping number 23 and 33. Okay? In your directions on some of those, it's going to talk about onto and one-to-one. Okay? Forget about onto and one-to-one. We're just worried about, is it a function? Alright? Otherwise, you don't have to worry about onto and one-to-one. Alright, so good luck with that, guys, and we'll see you tomorrow.